Now, before we move forward, let's do a quick review of the operators that you have in Python that help you do divisions, right? There are three main operations that we deal with uh, when we divide numbers. Okay, the first one is a normal division, okay, which is represented by the slash, and this gives you a floating point result. Okay, so if you divide, for example, 10 or 100, if you divide 100 by 10, the result of this division would be 10 decimal O, right? 10 decimal 0. Even though it is perfectly divisible, it could have said, Python could have said just 10, right? But it doesn't do that. Okay, it gives you a decimal, a floating point number. If the result is, if it's a whole number, then you have 0 after the decimal. If it's not, you have numbers after the decimal, right? You have non-zero numbers after the decimal. For example, if you try 5 over 2, you'll get 2 decimal 5, right? So this is done using the division operator. But Python also gives you two other operators. One is the quotient operator and the other one is the remainder operator, right? And just so you understand, the quotient always gives you an integer result which is rounded down to the nearest integer. Okay, for example, if you round down this number to the nearest integer, you'll get 2, right? If you round down, for example, 3.1 to the nearest integer, you'll get 3. If you round down 3.9, you'll also get 3. Okay, so essentially you just ignore the part after the decimal. Okay, now that's the rounded down version of a division. Now the quotient operator, which is the two slashes, like so, gives you the integer result which is rounded down, right? The integer result of division which is rounded down to the nearest integer. So for example, if you said 100 integer division 2, you'll get 10, not 10.0, just 10, right? If you said 5 integer division 2, you'll get 2, right? If you do 100 divided by integer divided uh, by 3, let's say, you'll get 33, right? Now there is another way of achieving the same result. uh, if you do something like this, int of some division, right? For example, int of 5 over 2, this will also give you the same result, 2, right? So essentially this and this, these two statements are equivalent. Okay, the third operator, which is the remainder, gives you the remainder of a division. Okay, and it does not need to be an integer, it can be a floating point as well. So it can be an int or a float as well, right? But it essentially gives you the remainder of a division. So if you have, for example, if you have 100 over 10, if you divide 100 by 10, right? If you divide 100 by 10, the quotient is 1, right? And the remainder is 0, right? Because it's, I'm sorry, the quotient is 10 and the remainder is 0 because it's perfectly divisible, right? 10 perfectly divides 100, right? So the remainder in this case would be 0, right? But if you try to divide 100 by 3, let's say, you get 33 1 over 3. So you have a remainder, right, which is 1. The remainder in this case is equal to 1, right? Similarly, let's say you try to divide 5 by 2, and what you get is 2.5, right? And this 1 here is the remainder. So the remainder in this case is 1 as well. Let's take another example. Let's say 7 over 3, right? So actually, let's take 7 over 4. So 7 over 4 gives you 1 3 over 4, right? That's the mixed fraction representation, right? Or 1.75, whichever you like, right? And the remainder in this case would be 3, right? So if you have an integer remainder, right, if the mixed fraction has an integer numerator, then your remainder is an integer, okay? But forget about floating point numbers for now, because you could also say something like 100.3 over 3, right? And that will give you a different result because the number that you're dividing itself has a floating point number. But we will ignore these numbers for now. We'll only deal with integers, okay? So when we divide an integer, we can do a division that yields a floating point number, or we could split the division into, we could split the result into quotient and a remainder, okay? And this is what we'll do in this module, and see how we can use these two very important operations to solve a variety of problems.